So we've looked at how to find the end behavior when a function is written in standard form. And what we need is we need to know the degree of the function as well as the leading coefficient. But what happens when the function is written in factored form? Okay? We can still do the same thing. All we have to do is we need to think about how do we change functions from factored form to standard form. And the way we change functions from factored form to standard form is we need to multiply them out. Now, if we distributed this polynomial into standard form, if we need to know what would our leading term be, we are looking for first the leading term. And in order to find the leading term, what we need to do is multiply all of the x values as well as any factors of numbers. Now, this is important, factors of numbers, and we'll look at that in the next example. But in this example, I don't have any factors that are just numbers. Notice all of my factors here are binomials. So to multiply, to find the leading term, to multiply all of the x values, what we're going to do, if we're looking for the leading term, we're going to multiply the 2x, the x, and the last x. We're just multiplying these out. So 2x times x times x is 2x cubed. So I found the leading term. Now what I want to do is I want to figure out what is the constant here. So to find the constant term, what we're going to do is we're going to multiply all constants. That means every single number that we see without an x, we're going to multiply it together. So to find the constant term here, we multiply all the numbers without an x. So we're going to take 3. We're going to multiply it by -1 and then by 4. 3 times -1 is -3. -3 times 4, -12. So I have found the leading term and the constant. Now, we're going to use the leading term and the constant to find the end behavior and the y-intercept. So, remember, in order to do that, we need to first identify what is the degree of my function and what is the leading coefficient of my function. So the degree of this function is going to be a 3 because my leading term will be cubic, and my leading coefficient is going to be a 2. Okay, now if we want to find the y-intercept, let's go over here and look at the y-intercept. The y-intercept happens whenever the x's are zeros, but we also know that the y-intercept is the constant at the end of our function. So my y-intercept here is going to be the point 0, -12. Now we can look at the end behavior. I have a odd degree with a positive leading coefficient. That means my graph falls to the left and rises to the right. There's my end behavior. Now, if we look at the next examples, we're going to predict the end behavior and the y-intercepts of each of these without actually multiplying them out. So first we need to find the leading term. Remembering that the leading term happens when I multiply all of the x values as well as any constant factor. So all of my x values here, I have negative x times 3x times x times x. I need to multiply this out. Negative 1 times 3 is going to be negative 3, and then count up your factors of x. I have 1, 2, 3, 4 factors of x, so it's going to be negative 3x to the fourth for my leading term. My constant, I multiply all of the constant values. So I'm going to multiply all of my constant values here. I should change, let's change colors. My constant, multiply all the constant values, 2 times 1 times negative 4 times 5. Multiply these out. 2 times 1 is 2. 2 times negative 4 is negative 8. Negative 8 times 5 is negative 40. So now I can find the end behavior by first identifying the degree. Well, the degree of my function is going to be 4. The leading coefficient is going to be negative 3. I have a even degree and a negative leading coefficient. That means my graph opens downward, and I have a y-intercept is the point 0, negative 40. Now we can look at part B. We're going to do the same thing. We're going to look for the leading term. So to find the leading term, I need to multiply all of my x values and any constant factor. My constant factors, negative 3 times x times x. Remember, a constant factor is always going to be a number just by itself, not inside parentheses generally. So my leading term here, negative 3 times x is negative 3x squared. Now I can find my constant. I'm going to change colors there. My constant value. I'm multiplying all the regular numbers. Negative 3 again times 6 times 1. So negative 3 times 6 times 1. When I multiply that out, I get negative 18. Now I'm ready to find my leading coefficient and degree. So the degree here is going to be 2. My leading coefficient is negative 3. I have a even degreed function with a negative leading coefficient. Same thing. This function is going to open downward. Both tails the same direction because it's even. Down because the leading coefficient is negative. And then my y-intercept is whatever the point 0 comma the constant is. So my y-intercept here is 0, negative 18. That's my y-intercept. And that's it. It's as simple as that. Okay, make sure you get these notes taken down and turn them in. And then we will do a little practice with this next class.